everyone, welcome back to this second part of PROPSIM walkthrough. If you haven't watched, please go back to the first video. I actually walked through some of the software part. In this second part of the video, I'm going to jump straight to the setting up so that you can see the effect. So let's turn on the signal, and this is how it looks like. We scan through between 400 to 500 meg. So this is how it looks like for the first view after you put up that machine. First of all, I want to start with setting up the TDL without any delay or any attenuations, because I just want to see how it looks like with and without the effects. So I'm going to go straight with the TDL tab delay line. So I'm going to create a tab without any delay or attenuation. We want to get a baseline of how it looks like before we add in the delay, the attenuations to your signal. So let's click that, channel modeling, TDL, channel studio, TDL. So you complain that TDL is already running because it's at the background. And what I'm going to do here is I'm going to send Windows signal here, and this is my TDL, yes. So let's go through a new one. So this is where the project folder is, which I don't really want that. Let's open up. Okay, let's change the folder. It should be under D, TDL example. Let's open up. Let's change that, D, TDL example. Okay, and let's open up. No delay. Okay. So as you can see on the screen, there's one here. Let's set the attenuations to 0. There's nothing there. And delay, just set it to 0. So there's no delay. There's nothing there. I'll set it to constant. And amplitude distribution just constant. No Doppler, no nothing. Center frequency. The only reason why we need to key in the center frequency is so that the software will calculate the Doppler shift on here, so that it stay within the reasonable Doppler shift. Calculation involved, you can't go faster than speed of light if you set your Doppler too high. So it all depends on the fundamental frequency. So once I'm happy with that, I save this as a project and I visualize. So I have one set Doppler, no Doppler, in fact, and there's no delay profile. So I generate, visualize, it's the same thing. You actually create a no delay 00.tab. So once I'm happy with that, I go to create emulations. Let's call it no delay tab. Today's date is this one, so no delay check, and bandwidth 50 meg. So this box can go up to 350 meg per channel, and I want to have a mobile ad hoc network. Just to make things simple, just one transmit and receive antenna. Don't really need full mesh, just custom. So this is where I'm going to click that, and I browse to my channel modeling. The one that I set was here, TDL example. So if you remember, this is the one that I created, no delay 00. So this is a channel impulse response. So I said something wrong just now. It's a dot tab, it's actually .cir, so 450 meg. So currently we don't want to see any shadowing, so just leave it as it is. We can cover that later. So once I'm happy with that, I click OK. Found a series of channels, so I just do the same thing for that. So before I click OK, I just want to click back on this radio 2 transmit to radio 1 receive, radio 1 receive, transmit to radio 2 receive. So you can actually change the name here if you want to, it's up to you. So the most important thing is I want to make sure that my channel model is correct. So I have the channel impulse response correctly done. So I click OK, next. So if I click here, so I make sure that my radio 1, which is field force transmitter, connected to channel 2 physically, and channel 4 physically is connected to radio 2. So even though it's bidirectional, I don't transmit anything back to the channel. So I click next, and then build and run emulations. Let's turn on the field force so that we can see what's going on. So this is before I click on run emulations. So this purely hardware, no emulations running. So I have signal turned on, I turn it off, I would see on Firefox on the right side. And when I turn back on, this is the signal. In theory, if I turn on the emulations right now, because there's no delay, there's no attenuations, I will still see a flat top, such as this. So I'm running the emulations right now. I can tell some data to look at. So how we're going to change the view is this the default? Sorry, this is not the default. The default will be like this. There's only one channel. So this is a channel impulse response graph. If you want more channels, more graph to be seen, you can click 1, 2, 3, 4 in quadrature. Then you go to here. Let's say I want to see the RF input power level. So I just look for my RF input power level. So let's say I throw this away. This is how I drag and drop. And this is the line graph for communication between radio 1 and radio 2. And this is how it looks like for the physical channel connections, which is this one, active connector. It'll tell you which one is responding right now. So as you can see, the CIR graph is constantly at the value here. It doesn't change in terms of delay or attenuations. So if you look at the Firefox, yeah, there's nothing changed over here because the signal is constantly there. There's no delay, there's no multipath and whatnot. So the next thing I want to do is to stop and then create a channel impulse response with 2 delay or make it 3 so that you can see the effect on the Firefox. Let's go to here. So let's say I have a channel power of 10, Rayleigh, attenuations, distribution, Doppler, jack, 100. Maybe it's a bit too high, so I'll just change it between 10 to 10 Hertz. Okay, then I add another path. So I have the power at -13. It makes sense, right? The your delay is longer, the further from the transmitter, but it's not the absolute situation. There's a time when your delay signal might be higher than the direct line of sight. So let's say I set it to 10 nanoseconds. So you can see that the graph is updating. So in another path somewhere in the middle, let's say we set it to 50 nanoseconds. So let's say we set it to maybe 20. Okay, the rest is similar. It's up to you. You can change anything you want, and I'll try to visualize it. You can see that the Doppler has changed according to my setup, and I'll generate it. Maybe I should save it as another one. 3 tap delay. Today's date and generate it. So I'm back here on the PROPSIM. I want to call out channel impulse response. I'll do this. Go to emulations, close and edit. Similar setup that, let's say 3 tap delay. Today's date. Same thing, bandwidth, ad hoc, 2 channels, manet. So this is where you're going to browse to the new channel impulse. Okay, it might have updated to the wrong part. Say save as, which is correct. Show my, yeah, TLDX. Visualize, generate. Let's see whether, right, it might be a bug. I don't know. Let's try this. Let's recall. Yeah, let's see whether it's in the system. File manager. Oh, it only has TDLX. So for some reason, okay, maybe I just close this. So I just realized that the file, for some reason, is still at the work folder here. So it's under user public documents, Keysight channel. So it's not a showstopper. Let's look at it right now. So it's under C, user public documents, Keysight channel work folder. So 3-tap delay today's date, and we have a channel impulse response. So for 50, so we want to make sure that it captures the same thing here. So it uses the same channel impulse response. So click next, same hardware setup, finish, build and run emulations. So as you can see, it's running. So let's turn on the Fieldfox. So this is how it looks like even before the emulation started. So it has a default setup, still the same thing. Signal in from Fieldfox 1 to Fieldfox 2. You can see that the signal is actually changes because of the delay. If you remember, we have 3 delays points and we have attenuations change. So this is how it looks like, the effect towards the signal from input and output. If we turn that off, we stop that, and this the first point at 0 seconds. So if you close it, oh yeah, it still maintain the last state. So let's see this one. So it reinitialize and then go back to the emulations. So if you run it right now, signal in with the effect of delay, this is how it looks like. So you might be interested to know, what if I only have one signal, let's say walkie-talkie 20 kilohertz bandwidth signal CW. Let's have a quick look. So in your source tracking, I turn that off. I set my center frequency to 450 Meg. I have output, so you can see that it changes a bit because of the attenuations profile that I put in my channel pulse response. So this is in LTSA mode. Let's change to spectral analyzer mode. Let's clear this out. Let's set it to blank. Let's change the acquisition to something faster, and let's set it to 0 span. Currently the sweep time is 20 milliseconds per sweep, so we probably have about 5 different time slots here. And if you're interested, we can actually make it faster. By default, if I turn that off right now and reset it to default, just nothing on, you will flat line. But because of the delay and the attenuations changes, you can see across time it does change. Okay, so this is effects from 3 taps, delay and also attenuations changes across time. So it's just to emulate 3 different signals coming into the same receiver. That is all for TDL, a quick run through. And the next video I'm going to cover maybe something else. Just stay tuned and just look for the next video and cover something in more detail so about this PROPSIM emulator. Thanks for watching.